Okay, so welcome back, and today we're going to start using logarithms to solve exponential equations. So I'm going to start with the one-to-one property for our logs. So remember that if we have the same base, the log of m equals the log of n, for m and n is any real number. Of course, b is the base, which means it's a positive real number other than 1. If this is true, if these two logs are equal, then the arguments must be equal. M must equal n. So we can use this property to solve exponential equations. And so let me show you. So what we could do is, notice first we have an exponential equation, right? But we can't, there's no way to get these bases to be the same, right? So how do we solve these? Well, that's where the logarithms are going to help. We could take the log of both sides, because if these two are equal, right, and this is a real number, right, for all x, right, this is a real number for all x, right, so we have two real numbers that are equal to each other, right? So if I take the log of both sides, that result, right, if this is equal, then this must also be equal too, right? It's a biconditional. So that means I can go ahead and take the log of both sides, and that result will be equal. Now, what log do we want to use? Well, we could use anything that we can put in our calculator, right? Because again, to solve this, we need to have something that we can put in our calculator. So we could use natural logs, or we can use common logs. I'm going to use natural logs. I'm partial to natural logs, but you could do the same thing with common logs. So I'm going to take the natural log of both sides. So I'm going to take the natural log of 5 to the x plus 2 equals ln of 4 to the x. And now we get to use some rules of logs, or properties of logs. So now what I can do is, now I can take the exponents out, right, using the power rule. So now I can pull this out in front, and I'm going to say this is the same as x plus 2 times the natural log of 5 is equal to x times the natural log of 4. All right. So now what do we do? Well, now I'm going to distribute, right? We've got to all solve for x now, right? Now I got x out of the exponent, so now I can solve for x. So the only way to do that is I got to break this up by using the distributive property. So this is going to become x times the natural log of 5 plus 2 times the natural log of 5 equals x times the natural log of 4. And now I'm going to subtract this from both sides. And so now if I subtract this from both sides, what do I get? I get 2 natural log of 5 is equal to x times the natural log of 4 minus x times the natural log of 5. Okay? And now all I have to do is factor out the x, and I'm pretty much done. So I'm going to get 2 times the natural log of 5 equals x times the quantity natural log of 4 minus the natural log of 5. All right. And so now, a couple different ways we could approach this. I could use the sum and difference rule, the quotient rule here. I can use the quotient rule. Okay. So I can write this as 2 natural log of 5. Or I could just divide by this, but let's keep going. 2 natural log of 5 equals x. Here, let me use another marker here. So x and this becomes what? This becomes the natural log of 4/5. Right? And so now what I can do is I can divide both sides by that. And so I get x equals 2 natural log of 5 over the natural log of 4/5. And so what is that going to approximately equal? Well, we could just put it in our calculator. And what do we come up with? Hold on a second here. Yeah, that looks right. Yeah, okay. Oh, so they leave it as an exact value, is the exact answer. So this would be the answer. Okay, so we're not going to approximate this. So this would be the exact answer. Okay. See you next time. We'll do another one. Have a great day.